Your agents show disconnected and builds fail with channel closed. The root cause: Jenkins agents don't automatically reconnect after a network failure. Let's break down Jenkins architecture, controller and agent, how it works, and the exact mistake behind that failure. The controller is the central orchestrator, like a restaurant manager. Agents are the chefs who actually cook. By separating roles, you can scale horizontally and avoid single points of failure. Running builds on the controller is an anti-pattern. A memory leak in a test suite can kill the entire CI system. After migrating to agents, we saw 99.9% uptime and 60% faster builds. The controller owns job configuration and scheduling. Agents own workspace and execution. To enforce separation, set the number of executors on the controller to 0. Permanent agents are always online. The controller initiates an SSH connection and launches the agent process. This is simple for static environments. Dynamic agents are ephemeral. The Kubernetes plugin creates a pod for each build, runs it, then destroys it. This is ideal for elastic workloads. Jenkins supports 3 protocols. SSH requires inbound port 22. JNLP is older. WebSocket is the modern choice. It works through firewalls and automatically reconnects on network failure. Always encrypt agent communication with HTTPS. Use the agent's secret token for authentication. Apply least privilege on agent permissions. Proactive monitoring prevents incidents. Use the Prometheus plugin to expose metrics like Jenkins Node Online. Set alerts for agent downtime and queue buildup. Static agents are always on but wasteful. Dynamic agents scale to 0. A hybrid approach uses a small static pool for fast feedback and dynamic for everything else. Labels route jobs to appropriate environments. For example, a Windows build uses label Windows. Combine labels with and for precise targeting. Agents fail. Use retry 3 in your Jenkins file. For dynamic agents, the Kubernetes plugin automatically creates a new pod if provisioning fails. Workspaces accumulate large files. Always clean up after builds with clean WS. Monitor disk usage and set quotas to avoid no space left on device errors. Migrate incrementally over a week. Start with non-critical jobs. Use labels to control placement. Monitor for any builds still running on the controller. This is the same issue we highlighted at the start. Here's exactly why that happened. By default, Jenkins agents do not automatically retry reconnection on network failure. When the connection drops, the agent process exits. The controller marks the agent offline indefinitely, and builds that were running are lost. The agent command lacked WebSocket and retry parameters, causing the agent to exit on network failure without reconnecting. The fix is to configure agents with WebSocket and retry settings. In agent configuration, set launch method to WebSocket and add WebSocket to the agent command. This enables automatic reconnection. Without WebSocket, agents do not automatically reconnect after a network interruption. The agent process exits and the controller marks it offline. Always use WebSocket to enable auto-reconnection. Running builds on the controller shares resources with the UI and scheduling. A memory-intensive build can OOM the controller. Set executors to 0 to enforce separation. If a job specifies a label that no agent has, it stays queued forever. Ensure agent labels match job expressions. Use consistent naming conventions. As of Jenkins 2.44+, the JNLP protocol is deprecated and may be removed in future versions. The article correctly recommends WebSocket, but it's worth noting that JNLP agents will still work for now, but should be migrated to WebSocket to avoid breakage. Also, the JNLP URL parameter in agent launch commands is still used for WebSocket agents, but the WebSocket flag must be added. The article mentions using WebSocket, but doesn't show the full command. Here's a concrete example for launching a WebSocket agent with automatic reconnection and secret from a file. In production, agent secrets should be rotated periodically. The article mentions using credentials, but doesn't address rotation. Use the Jenkins Credentials plugin to store secrets and update them via API or UI. For Kubernetes agents, inject secrets as environment variables from a Kubernetes secret that can be rotated without restarting agents. To debug agent disconnections, check agent logs with kubectl logs. Use the Jenkins API to verify agent status. Monitor metrics like Jenkins node online in Prometheus. Let's run through some common interview questions. What is controller agent architecture? Separates orchestration from execution for scalability. How to set up SSH agent? Generate keys, copy to agent, configure node in Jenkins. JNLP vs WebSocket, WebSocket auto-reconnects. JNLP is legacy. And a few frequently asked questions. Can I run builds on controller? Technically yes, but strongly discouraged. What's the difference between static and dynamic agents? Static always on, dynamic on demand. How to clean workspaces? Use clean WS in pipeline post section. To summarize, always separate controller and agent responsibilities. Use WebSocket for reliable connections. Leverage labels and dynamic provisioning for scalability. Monitor and clean up to keep your CI system healthy. Ready to go deeper? Up next, Jenkins Freestyle Jobs, then Jenkins Freestyle Job Tutorial, then Jenkins Plugins. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.